Yeah, so my day job right now is to drive the evolution of the language itself forward. But at the same time, I get to dabble in lots of things. So you can blame me for much more than C# itself. So even though it's dark in here, I want to ask before we get started, how many people were in George's talk? Oh, that's good. Yeah, good. We have some. You get to compare and contrast. Great. And so there'll be a survey when you exit the door. Which language are you going to do your next project in after this double session here? I'm just joking. So also, how many people in here are .NET developers? OK, that's a lot, but that's thankfully not all of you, because I'm kind of hoping that we can pick up a few more. So great. I am going to. People have a lot of. We've essentially been the butt of a lot of jokes. For a long time, George was pretty gentle in his talk compared to what I thought he might. But it's been. We don't like being the center of ridicule. So we're kind of thinking about changing a lot of the perceptions. Or working on changing a lot of perceptions around C# and the .NET ecosystem, not by marketing measures or speaking about things differently, but just changing a lot of the stuff that really did suck. Okay, so I'm gonna tell you about a bunch of the things that we're changing, and then I'm gonna sort of home in on and double click on some of the things that I'm deeply involved in out of that list. And I'm gonna do a few demos as well, because at Microsoft we like to do live demos and kind of crash and burn in front of everyone. It's happened once. It could probably happen again on this trip. And we're a little short for time, so I'm going to demo multiple things at once. But I hope you'll be fine with that. You're pretty smart people, so you should be able to follow. I'm going to try to talk about this thing in a way that is it should be accessible for people who don't know C# but are maybe familiar with Java or something like that. If there's a thing or two where I get too inside, or you just shout or ask or something like that, I really don't mean this to be for just .NET developers, but hopefully all the .NET people in the room still find this interesting too. Okay? So we're really trying to change our tune here, and that's sort of up and down the stack. So first of all, you probably think that, or many of you probably think that you can only use C# on Windows. And that's because the reason you think it is that it's basically true. There are implementations of C# and .NET for other platforms, but we didn't make them. And people have had sort of varying success with that. It's certainly not been supported by us in the way that it is now. We're really giving up on that. We want C# to run everywhere, so we're porting .NET we're doing it ourselves, porting it to what we call the core CLR, the core.NET, to Mac and to Linux, and we're doing it in an open source way, so we can get more ports over time to different platforms and so on. We really want to be wherever you are, right? Choice of C# shouldn't be one that's constrained to being just on one platform. And hey, a lot of those Linux VMs run on Azure. That's fine with us. You know, we still get the ka-ching. So we shouldn't be so narrow-minded about this. You also probably think that if you want to write in C#, you probably need to fire up Visual Studio. And if you fire up Visual Studio because you happen to be on a PC physically or running it on a Mac as a VM, you should get a great experience. And the things I will show today will be in Visual Studio. However, we don't want to be just focused on providing a good tooling experience in Visual Studio. We want to build our things in such a way that it's easy to write great tooling for C# and for Visual Basic in your editor of choice. Again, so it's another one of those, come to where you are rather than make you go to a particular place to use that stuff, right? So, and how specifically we're doing this, I'll get into that a little more later in the talk. Another thing which relates to something that George talked about as well with the modules, like he mentioned DLL Hell, we are also moving with the core CLR to a model where you don't have to rely on .NET as a system component that you kind of pull on that's installed somewhere centrally on your machine. Like you can deploy a self-contained app that has the libraries that you rely on and nothing else, and doesn't behave differently because you happen to be in a different environment. So, so making .NET more modular is something that just as with Java that we've, is long overdue, and so we're working actively to do that. So you just pull in what we call NuGet packages as you need them, and you deploy, and everything stays together. We're also working pretty hard on facilitating compilation to native code, right? So you can continue to run on a VM. We have the good old Windows desktop VM runs better than ever, and the core CLR is also a VM that is that's ported to different platforms. But if you want to compile down to native, we want to support that as well. And so we have a lot of work. Right now, the only compile to native story that's fully released and in RTM is when you write universal Windows apps. But that's a technology that we are working on spreading out to more and more platforms and more situations. So you can get rid of that startup lag and the various performance problems around running on a VM, if you so desire. One thing that I've been deeply involved in is the so-called Roslyn project, which I'll talk a lot more about. But the main thrust of it really is that we've gone from taking all that understanding of C# code that we do in our compiler, that's been locked up just inside this black box thing that you invoke that produces source code out, or that takes source code and produces executable code out the other end. And we've taken that and opened it up so that it's an API that everybody can use for their source code understanding. And that's something I'll drill into a lot more in this talk. Finally, I think, and this may be the biggest shift that you're seeing, and this is sort of a part of a trend across Microsoft, is we're taking our assets from being proprietary and something that we want to try to milk for profit, and just throwing it open source across the board. And when we say no open source, we don't mean there's this window over here where we exhibit our code if you want to have a look at it. Right? We mean that we work in our GitHub repo just like everyone else. We take plenty of external contributions to our source code. Whenever somebody wants to use C# from their editor or port the CLR to their platform, they just do a pull request like everyone on the team does. And that's really starting to ramp up. The first Mac port of the core CLR was done by someone external to Microsoft, for instance. So we want to be open source in a big way, that we're actually building a community and sharing the responsibility for the direction of the whole stack of stuff. OK? So don't just believe me. Stay here and watch some of it. And let me show some of the details of it, and also go have a look around and see what you can do with .NET today. So I'm going to drill into this project Roslyn that is really about the compilers and tool support to begin with. So we had this idea that we should take our C# and VB compilers that people know and love and trust and that are fast and reliable, and we should just rewrite them from scratch. So that's a great idea, right? That's the kind of thing that can make managers choke on their coffee. But the reasons why we were entertaining this idea, and I'm talking back in like 2008 or 7 or something like that, that these ideas really started to ferment on our team. The reason was that we had a bunch of really big problems. We had C++ source code that wasn't well architected. It's the stuff that you kind of throw together for a V1, and you fully intend to clean it up later, but instead you just keep piling stuff onto it. So at this point in time, we had a source code that we were essentially scared of, and every change was kind of a risky undertaking. Right? So we couldn't. It was hard whenever we wanted to evolve our languages and whenever we wanted to evolve our tooling on top of this source base. It was out of the question to use it in any way to support C# in other IDEs or for other kinds of tools that rely on language. And there are many kinds of those, and I can list those out in a bit. Just getting the compiler and the IDE and what other people built for themselves on top of the language to agree on what the language actually meant was a problem. And we were all C++ programmers, right? So we didn't get to use C#. We were building something, but we weren't using it. It's your unique opportunity when you're implementing a language, is that you can use your product to build your product. And we were missing out on that opportunity. That's just stupid, right? So we had really, really good motivations. Now, the challenge here is, so I'm just going to speak a little bit about it's going to make sense to you. I'm going to speak a little bit about the challenges we faced implementing. Why do you care? You'll see in a minute why it matters to you as well. There's sort of a traditional dichotomy between compilers and editors or IDEs around how they implement the way they understand a language. Okay? If you're a compiler, you're a batch. You do a batch operation that's optimized for throughput. You focus on correctness. You'll only compile code that's completely correct and prevent errors from coming through. And you sort of only relate to source code that somebody wrote already. Okay, so you're kind of reactive. Whereas in a tool, you want to be incremental because the code changes all the time. The measure of efficiency is a different one. It's about responsiveness. It's about whenever somebody hits a key, whenever they press the M key or whatever, about immediately being live and responding to what they do, right? They hit dot, something immediately happens. So responsiveness is a very different performance measure from throughput. Error tolerance, obviously, 90-some% of the time that you are editing, your code isn't correct, right? You're in the middle of building it, so obviously it isn't. So you have to be really tolerant to all kinds of things being half done or being a little off. Your point really is to enable the programmer, enable them to navigate and create and explore rather than prevent them from doing something wrong. And so in order to achieve that, you want to essentially be predictive. You want to say, what are they likely to do next? And then facilitate that so that the developer can be as productive as possible. So there are all these kinds of reasons why language understanding in these two worlds why that is very different. Right. Nevertheless, we have gone against the grain here and essentially embarked on a project to build those two into one thing. And part of the reason is that there are so many other language scenarios that are increasingly important, useful to developers, and we want to facilitate those as well. So it's no good kind of building your language understanding per application or per scenario, right? So just to here's a long, long list. I won't go through them all, but we're going to look at some of them later. Like you want to provide feedback on code in various ways. You want to refactor and transform code. You want to build an updater tool that updates to the latest version of your library. Scripting, REPLs, documentation generated from source code, all kinds of static analysis on vast source bases, maybe figuring out how much is this used versus that, which kind of patterns do people use when they code, telemetry, back from tools, metaprogramming of all kinds, right? Generating source code based on other source code or based on other kinds of specifications, injecting, weaving, all that kind of stuff. It's all based on understanding the basics of the C# language or whatever language you're doing these things for. So we want to facilitate all that. Even if we don't build all of it ourselves, we want to make sure that it's facilitated, right? And if you come right down to the core of what we wanted to achieve and what we believe we build is, there really should only need to be one source base in the whole world that understands C#, right? We should build that. We should build something that is the only thing the world will ever need in understanding this language. And we should share it with everyone. We should share it so that everyone can use it for their purposes, so that everyone can contribute to it, so that it works for their purposes, and so on. And that's what we've done. That's what the Roslyn project is. Make sense? Yeah? Good? OK. I want to talk a little bit about language evolution. C#, obviously, when you own a language, you kind of have this, how quickly should you evolve your language? Either you can evolve it a little bit or you can evolve it a lot. That's sort of one spectrum, right? And both things will essentially lead to certain doom over time, both ends of the spectrum. So it's kind of a balance here. Like if you evolve your language too little, as the rest of the world evolves, as there are new demands, as you have new real-world requirements to how you code, your language will become less and less relevant. It'll stagnate, and it'll become something that is for maintaining existing code only, legacy, right? The L word. So that's really bad. On the other hand, if you evolve your language a lot, it's going to explode. It's going to become too big. Nobody can understand the whole language. And you kind of get another messy situation where the language chokes itself to death on too many new features. So we kind of have to find our way on this spectrum. And that goes for everyone who owns a language and is thinking about how to evolve it. So we think C# is right about here, right? This is very accurate. I've got a very accurate metric in my pocket that I'm not going to share with you. No, just kidding here. We're sort of around there. We think that C# is a language that should evolve pretty fast. It should evolve in a responsible way, and we want to make sure that everything we add fits as well as possible into the language, doesn't change the core spirit of the language that a lot of people, like not as many as Java, but that a decent amount of people really know and love and are dedicated to. But at the same time, it's really important that the language doesn't fall behind. As long as possible, it should be a worthy choice compared to some of the newer languages that are out there, right? And we should work to keep it like that. Quick overview of the evolution of C#. The first version of C# was maybe vaguely inspired by other programming languages that may or may not have been talked about earlier today. I think there was a little bit of envy back then. So if you can't join them, beat them, right? There were a few differences. Like, we actually had value types already back then. And you're welcome, George, to have a look. We have some tricks. It's pretty good. I applaud that you Java programmers will get it too. Of course, there's the quicker way that you can get value types. We added generics a little after Java. We have generics that are actually part of the runtime, which has some pros and cons. It has mostly pros so far, in that the runtime can really do the specialization that George talked about and so on. It also helped us, actually, with the next couple of releases, our language features were built on top of that generics in the runtime. But it does mean that if I get the question that George got about higher kind of types, that's a much harder proposition in C# than in Java, because we'd have to fix the runtime up to do it, whereas Java has erased generics. C#3, 2008, we got lambdas then. We got query syntax. We have some different method names than the filter and stuff that were in George's slides. But essentially, that same kind of thing came in with the idea that lambdas and a kind of higher level abstraction over, for instance, going through collections. They go well together for querying and stuff, okay? C#4, some dynamic stuff that, well, we did it. That's also when we got our concurrent, like a task parallel library that enables good high-level abstractions for concurrency. That's probably the more important thing that happened there. C#5, async, for direct language support for asynchronous programming. And then C#6 that came out this summer is the first one, last summer. It's the first one that's based on the Roslyn compiler. It has essentially just all those little features that we were too scared to add in the old code base are finally there. So I'm going to show a few of those. And then C#7, who knows? But I'll extrapolate a little on that thought later as well. So right now, let's go and demo. I said I would demo a couple of things at a time. Let's go and talk about the REPL that we built on top of Roslyn and show some of the C# features in the REPL. So do people know what a REPL is? A read-eval print loop. It's essentially something that's been around since the 50s. Hang on. And we just we sort of really only got to it now. Let's see. Here we are. Of course, you can run a REPL, and we have a version of it that you can sort of run in the command line. You type some code, it gets evaluated, you get feedback from the evaluation of it. It's a little nicer. We sort of have a 21st century version of REPLs. If you run it in your favorite editor, as long as that's Visual Studio. The other ones could probably catch on to this easily because it's based entirely on public APIs in Roslyn. So here's a REPL. It's essentially a glorified calculator, right? You can write C# expressions and they're immediately evaluated. Yeah. You could console.write line something. let's write something nice. Hello, YOW, Brissy, 2015. Okay, and evaluate it, and it does its thing. Yeah, it does what you ask it to. That's nice. So let's look at one good thing about REPLs is they'll let you explore APIs and language features and so on and play with them in a much more immediate way. So let's do that. Let's explore some of the C# language features that we added in C# 6. So we added something that Java has had for, what, 12, 13 years now, the ability to import static things. Using static system.console, for instance, is, just puts all the static members of system.console into scope. And so if we go and repeat that line here, what you'll see is that as soon as the analysis catches up, console kind of fades out there because it's no longer necessary. That's Roslyn sitting behind saying, hey, let me check if there's something you could do more easily and gray out the superfluous stuff. So you can write it like this now, right line. We also have interpolated strings because all the cool kids have that now. So we want to also be cool. It's the idea that formatting strings should be easier, right? So you can have now an interpolated string, which you do by putting a $, because we like basic at Microsoft. So if you put a $, in front of your string, you can put curlies inside, and that gives you a little hole there you can put expressions in. So now it will still print out 2015, but now it does it by evaluating 2015 as an integer expression. So if we put 2014 plus 1, it would do the same thing because it's evaluated. Or we could go and actually make the code reusable next year by saying datetime.now. And you can see why this is a slightly nicer REPL, because it's actually an IDE as well, right? Now dot with completion and stuff dot year like this, and it's still 2015. Or we could go and say, you can also declare things in a REPL. So we could say var the awesome place equals Brissy, and then you could go and there we go. There you could go and insert that here. So the awesome place, right? So another thing is that you can declare functions inside of REPL. So let's do. So you can see I'm demoing the REPL and C# 6 at the same time here to save time and get out of here in time. String. Let's take the greeting and spell that. Let's take the greeting and actually let's reuse the string from here. Let's take the greeting and return it from a method. Right? So let's define a top-level method in the REPL here. You can't do that in C#, maybe one day. But let's do it so that you have string greeting open curly, close curly. That's how you would define a method in C# until recently. But we now added the ability to have, just like in a, you have to return it as well. Just like in lambdas, you can have an expression-based lambda instead of having like a body full of statements in it. I believe you have that too in Java, right? You can now just write an expression-based function here. So it's just reducing the boilerplate a little bit, but now you have a method that is defined just as with an expression body. Okay. So if I evaluate greeting in my REPL, I get hello YOW Brissy 2015. Okay. That's the REPL, and that's C# 6. There's plenty more features in C# 6, but I don't want to kind of dwell on it too much. But ask me later if you want to see more. Instead, I want to go back and talk a little about what we're thinking for the next version of C#. Okay, so we just shipped C# 6 a couple of months ago in July, I think, late July. So we're just now starting to work on what should be next. And instead of sitting down in a room with the blinds down and kind of plotting a secret, what should be the big reveal 3 years from now, we're doing our design work in the open. Like we put we have C# design meetings, we put the notes from that out in the open, we take proposals, we discuss them on GitHub. In general, we do this stuff in public. So it's a little more like, I know Java's always done this, yeah, but with more politics. Because Java is so multi-vendor that it really hurts. But we're not quite there yet. Maybe one day. So some of the things we're thinking about. So we sort of have this general idea that it's all very well to be sort of a 90s era object-oriented programming language. But one of the things that's really changed is the world is now distributed. A lot of people are working not so much maybe with self-contained objects with behavior and immutable state, but they're working with data that travels back and forth between different running pieces of code, right? Distributed concurrent programming. And we kind of took our cues from that a little bit already in C#5, where we added async, support for async programming, so it's easy to deal with latency and the natural concurrency of the world, of the web, of the internet. Easy to do that without breaking out of your sort of usual style of coding, if you will, without callback hell. That's another hell right there, callback hell. But we think there's more to it. We think that it should be easier to work with data as opposed to objects. So a little part of that, sort of coming at it a little tangentially, is we want to add tuples to the language. OK, it's about time. So essentially, the main purpose of tuples probably is the most common use case is you want to return multiple things from a function. Why should that be so hard? Can't you just let me list the things to return already? And so tuple types, a natural place for them to occur would be as a return type there. There's a few languages now, including Swift, that do tuples where they actually allow the different elements of the tuple to not just have a position, but to have a name, right? So when you get 3 strings back, and you can't remember which is the first name, which is the last name, and which is the address, you know, they can have a name. Okay, so we're thinking name tuples. There should be a way to, the names also help that you can get the tuple and you can dot into it with using those names, but there should probably also be some kind of positional deconstruction for it. Okay? So tuples is one thing. Another thing, again, talking about sort of data that comes in over the wire or whatever, you have a lot of structured data, and sometimes you want to figure out which shape it has and do something if it has a certain shape based on the knowledge of it having that shape, right? So we're thinking about pattern matching as well in the language, where you can, for instance, the is operator in C# today is one where you can just check whether a given value has a given type, and you get a Boolean saying true or false. We want to extend that a little bit so that the thing you check against could be more than a type. It could be a pattern. For instance, the pattern, a simple pattern here is point P, where as well as checking that O is a point, you also actually take it, if it's true, you take it as a point and put it into the variable P, so that in subsequent code that is sort of in scope of that check, you can use P. So you don't have to first check, then cast, or something like that. Right? So it's a natural way of working with objects when you are trying to realize their shape and do something based on the shape. The kind of combination of checking and assigning to variables, if you will. Yeah, obviously, so that would be in scope in more places. Maybe we have recursive pattern matching, where somehow point knows is able to declare that x is first, y is second, and you can write recursive patterns that checks maybe that if x is 5, put y into that variable there, and you can use that subsequently. Okay? Is that going to be useful? Yeah, I get a thumb up. Whatevs. When's lunch? Okay. Of course, you can use patterns in other places than the is statement, right? So it's a new concept in the language that can be applied in multiple places. We'll try to apply it where it's kind of not breaking too much with the feel of the language. So a natural place to generalize is a switch statement. Good old C switch statement, where you still have to say break every time. I'm sorry. Maybe we should do something about that as well. But you know, instead of just saying case and then a constant value, you can now put patterns in your case statement. You can switch in anything, and you can have like very expressive patterns saying, if this pattern applies, you know, go into this case here. You could even have you could have extra conditions attached to it. You say, if it's a string, you know, the case where it's a string, then call that s and check that s is longer than 0, and then fall into this case here. So now you can start seeing how you can write code that takes something that has multiple different possible shapes and easily declaratively say, what should I do or produce for each shape. We're also talking about having an expression-based version of this, that instead of having statements that happen for each case, there's an expression that gives you a result for that shape coming in. One thing is sort of everything defaults in C# and Java to objects with state. So mutability is the default over immutability. And reference equality is the default, and all these kinds of things. And that's, if you're working with data and with values, that's just all wrong. And so you have to write so much code in order to get to where you want to be. Of course, you could go use F# instead, and I encourage you to do so. But a lot of people don't. That's not the right solution, right? So we take inspiration from that and say, okay, there should be a way to say that really shortly. So there should be some kind of record types that aren't a new kind of type in C# that you kind of have to wrap your head around, oh, there's a new kind of type. It's simply, the way we think about it is, it's simply an abbreviation from saying all that stuff that changes the defaults, right? So when I say first and last up there in a sort of new record syntax, it really means implement all the stuff, give it a constructor, give it a positional deconstruction that I used in the pattern matching before, give it an equals that's value-based, and so on, right? So there should be a way to work just as easily with values as you do with objects, without kind of breaking completely out of what the language is about today. Should be easy to create immutable objects from scratch, or create immutable objects from other objects, like what we call non-destructive mutation. Take a value and get another one that's like the old one, except for little changes. Okay? Maybe we have a static type system that has no idea about nulls. Other languages know about null and tell you if they know if you can express whether a variable should be able to contain null or not. And if it's not able to contain null, then it will enforce that you don't assign null into it. And if it is able to contain null, then it will enforce that you check for null before you dereference. We can't sort of, in version 7 of a language, we can't go and do something that's very sort of radical and harsh and full of strong guarantees, suddenly adding a null awareness to a type system. That would break a bunch of existing code. But we could do something. So we're thinking about a sort of warning-based system that could help you find most of your null reference exceptions. It won't give you guarantees. That's, compatibility, sorry. But it could tell you lots of things based on warnings and maybe some opt-in. Right, so if you had two versions of the string type with a question mark, you could express, this is a string variable that is intended to contain nulls. And the other one, well, it might, but it's not intended to. And we're going to try to keep it from it. Okay? Then, yeah, we would let you assign null into one, but not the other, except, we would, but we would give you a warning, whether you do it directly or indirectly. But on the other hand, we would protect you a little bit from dereferencing things that could be null. So you'd be able to opt into or get a warning there saying that end at length, that's probably not a good idea because you said it might be null, and so you might get a null reference exception here. Except if you check for null. And so we'd have to be able to recognize, we'd look at your source code and say, do we think he's checking for null? Trying to be pretty smart about it. And if you are checking for null, then we would let you dereference. And if you really know it's not null, you check some way the compiler can't see, we would introduce a damn it operator saying, I know what I'm doing. Just do it already, and I'll take the exception if I was wrong, all right? So something like that is what we're thinking as well. So changing gear from the language level, I want to talk about something that's available today, but sort of on the advanced end, so I saved it for last. Messing up the chronology here a little bit. George was much better at that, sorry. I want to talk about one of those scenarios that is a language-based thing you want to enable. Okay, so this is the idea that you can write your own custom analysis, custom diagnostics, if you will, for source code. If you have, in your company, you have a style guideline, or in your API, you have certain ways that the API should be used, it'd be nice if you could write something programmatically that lets people know that they're doing something potentially wrong and give them warnings and errors, just like the language does, but for more specific scenarios that aren't sensible for us to implement in the language itself. Hey, we don't like var around here. You could build that analyzer to smack people when they get var, when you use var. That'd be great, right? Or the other way around. Actually, you could have both. And then yeah, anyway. So, and as well, once you custom diagnose something, it'd be nice to be able to provide a custom fix that people can apply, just like a built-in refactoring. So that's what the analyzes and fixes framework does. And I'm going to show it to you, and we're going to use it. So essentially, and this is the last part of my talk, the one that may crash and burn. And we're pretty close to lunch, so if it does, I'm sure you go eat and get your sugar up, and you still have a warm, happy, fuzzy feeling about me, even in that case. So the idea here is that you, as non-compiler geeks, you should be able to go and write something that does something with the language. So the Roslyn API is really an object model of language. Let's go use it, OK? So we have this thing called an analyzer and provider. Right now it's just in VS as a project type. If you select that, it will create a sort of default analyzer that you can then go and hack in. And all I did was rip out a few things and provide a few strings. And other than that, I haven't implemented much yet. The way it works is you initialize by signing up some custom analyzers. And I'm signing up the analyze node here method. I'm going to fill it out with the logic to actually analyze. So what am I going to analyze? Well, let's enter debug mode, which I did now, which when you do it on this project, what it will do is, and this takes a little while, so I'm going to talk over it while it does it. The way it debugs is it starts a nested version of Visual Studio up so that you can try your analyzer live on code. The idea is the analyzer should work on keystrokes. And so I want to be able, the debugging should be, I'm able to try my analyzer in sort of this nested Visual Studio that has it installed. So now I open a project in the nested version of Visual Studio that's run by the outer Visual Studio that I'm writing the analyzer in. And I have some code here that is, some people would say is not, a good form because it doesn't use curlies around the bodies of the if statements. And so what I want to do is write an analyzer that complains about that, but only if you don't have curlies around your if statement. You good with that? No, somebody's not. Yes, good. OK, and we have 10 minutes for this, so let's see how far we get. It took a while to kind of get into debug mode here, so I'm going to simultaneously demo the much improved support in Visual Studio for edit and continue by not actually leaving debug mode while I code this analyzer. So what I'm going to do is I'm going to go out to the outer, let's see, where is it? Here, the outer Visual Studio. I'm going to put a breakpoint here where I'm going to write the analyzer. Then I'm going to go back to the nested Visual Studio and do an edit. And if I'm lucky, that edit notices that there are if statements. And I registered an analyzer to go on if statements. And so I hit a breakpoint here calling my custom code from within Visual Studio. OK? So now I can get to work. I have a context there. Let's have a look at what that is. We can actually, let's see, we can hover over it here and see it live because we're in debugging right now. We actually have a live object there. So what you can do with this context that comes into an analyzer is you can see what syntax node you're stuck on. You can report a diagnostic if something was wrong with it. And if you want semantic information, more than syntax information, you can dig into that as well with the semantic model. So but let's just start by looking at the node here. We can see that it is indeed an if statement. So let's get it as an if statement. By using the syntax tree that is really just an object model of C#. Right? So we can say var if statement is there's that node as an if statement syntax. And now we can if statement, the code, a little bit of OCD here. OK, it would have worked anyway. So now let's go and explore this if statement that we got. What is it that we don't like? We don't like if its nested statement isn't a block. So I'm going to get its nested statement and get the kind that it is. And I'm saying if that's not, hang on, that is a method. And if that is not a block, something that has curlies on it, then I want to report a diagnostic. OK, so let's report a diagnostic. We saw that we could do that on the context. So let's take the context and report a diagnostic. What does it need? It needs a diagnostic to report. OK, Let's report a diagnostic. I don't have one yet, so let's go and use a refactoring. We have lots of new refactorings now based on Roslyn. Let's go and create a diagnostic. Diagnostic.create. What does it need? It needs a descriptor. I cheated and made one in the boilerplate code up there. That was wrong. What did I call it? Rule. That's what I called it. There we are. It needs a location, whatever that is, and it needs to be told what kind of statement I stopped in here because it's going to print that out on screen. OK, there we go. Now we just need this location thing. What is a location? Well, that is wherever in the code we want to have a squiggle telling us that there's a bug. So let's do that on the if keyword. So we can say if keyword. We can take the if statement's if keyword, because this is not an abstract syntax tree. This actually has a representation of every instance of every keyword in the whole code, so it's this particular if keyword, because then I can go and get its location. Where is it in the source code? Right. So there we go. I think I did all I needed to. So in these few lines of code, if everything goes well, I am now doing everything I need to get a squiggle on my code whenever there's not a block in there, right? So imagine how easy it is for you to write your own rules that are smart to code, if you will. OK? So you see the squiggle on the second one, but not on the first one. But if I edit here, it gets called every time I edit, and now it gets a squiggle on the first one as well. So it would be nice also to offer a fix. So I have let's see, where are we? I have a code fix provider as well that I can do here, where I sign up this fix async method to be called whenever this particular diagnostic gets hit, and then I can offer the user some help. Let's see. We need to get in there. And let's just put a breakpoint at the end there. Actually, let's put it all the way at the end. And then let's go and trigger this code to be run. So inside of my nested Visual Studio here, now you see there's this light bulb that says an if statement should contain braces. OK, let's go and see what options I have to deal with that. Well, there's an add braces fix registered, and that calls my code and runs it. OK? What does this code do? It asynchronously returns a document. What is a document? It's an object representation of the whole file here. So here's an interesting thing. The syntax tree, the whole object model, is immutable. So we're actually one of the sets of people who would like to work more with immutable code, who don't like necessarily to have mutability be a default. Right? It's an immutable tree representing the code, and immutable data structures representing the semantics and everything. So what I need to do is I get the old model, the old document, and I need to return the new document. I need to do it in 4 minutes. So I go in here. All I get is the diagnostic. I find the document. I find the location. At the location, I find the token that is there, which is the if keyword. And from the if keyword, I go up to the parent, which is the if statement syntax, and get that out. And that's what I have now. So now I want to produce the new one, the fix, the one that I want to return at the end. So we should create a new if statement. I can't modify this one. It's immutable. And that is really useful because because then I can have both at once. First of all, I can do everything in parallel. I don't have any concurrency issues, but also I can have them both around at once. So I can create diffs and stuff, and you'll see that in a minute. So I need another if statement that's like the old one, except it's with a different statement, namely the one that has a block. So let's create a block. Syntax, wrong completion here. Syntax factory dot block. And that block should have the original if statement's, man, fat fingers here, statement inside of it, right? You see what I'm doing there? Building a new one from the old one. Var. Then I need a new root syntax tree, which is the old root syntax tree with where we replace the old if statement node with the new if statement nodes. I'm zipping back together a new data structure from the old one with just the spine replaced here. And finally, we need a new document, which is the old document. New document equals document dot with syntax root new root here. OK? So now I have a new document that I can return instead of the old one. I wonder if this works. Let's remove the breakpoint, and let's go up and execute from where we got to. I like debugging. So I'm still in debug mode here. Hopefully this all works. If anyone can see any reason why not, thank you for staying silent. So let's go and try this again. Add braces. Whoa, see there. It shows the new code and the old code just based on that little transformation that I wrote, that you could have written. No problem. It shows old code and new code because it diffs the two syntax trees because they were immutable and didn't get mutated and destroyed. And now if I choose this, it inserts the new code. Right? So with this, you can build a whole infrastructure based on that same object model of code that our compiler uses and that our IDE uses. It's all that shared thing in the middle that's going to give you wonderful language-based experiences for years to come in C#, right? And that you can contribute to because it's open source, and that I'm obviously way too happy about. Like, this is disgusting. But hopefully that gave you an idea of both where we are going with concrete things that you as an end user can use, and how we're enabling an ecosystem for tools on different platforms and so on, so that hopefully working with C# is relevant to you in the future, and it should make you a happy camper. All right? Thank you very much.